Continuing practice exam 5, problems 11 through 15. Here we have a problem that's mostly a review problem here, but that could definitely be on the exam tomorrow. Let's look at this here. You can see we have answer choice here with SOCl2, a couple of those. One of them here, well, let me just go through it and show you here. If we carry out a reaction with SOCl2, say like in problem B here, we see we convert that. I'm going to use pH as a representation for benzene. But if we convert that to an acid chloride and then we carry out the reaction here with the cuprate, cuprates will convert this to a ketone right here, and we will get the desired ketone from this here, like such. So that answer works out, B, but you see we have an answer choice with both of them in it, so we have to check to see if C is correct here in this case. And you can see C is methyl lithium. That is a strong base that will react with that H. That will not work whatsoever. That would be an explosive reaction here. So B is the only answer on that. Okay, here we have another case where we have a couple of different answers that could be the correct answer choice. Let's go to B to see if that one's correct here. You can see with B we have a cuprate that's reacting with an alcohol. That's the wrong functional group here. We have kind of a strong base reacting with an acid right here. So B is not correct. So now we have to go to C and D to see if that would work out. And with C here and D also, the first two steps are to make the carboxylic acid. So also to say step 1 and 2, we make a carboxylic acid like this, acetic acid, and then excuse me, that's after only step 1. We make a carboxylic acid. Excuse me, I'm all out of practice. Getting all nervous. So here we have a conversion to a acid chloride right here. And then here's where the distinctive step comes in. We notice that to get to this point, we actually have to add 2 methyl groups to that. There's 2 methyl groups right there, and this is a trick right here. The 2 methyl groups do not add in that case. That would make just a ketone, in this case acetone. Incorrect. D is the only answer on that. Okay, number 13. Here we have a type of retrosynthesis, and this one's rather extensive here. I am going to look through these here and see if I see the correct answer choice. Let's see here. Let me see. First thing we want to do here is we want to check carbons. How many carbons did I add? 1, 2, 3, 4. That sometimes can reduce the difficulty. We have 5 carbons that we need to add. So let's count A and see if we can eliminate that. 1, 2, 3, 4, 5. That one does have 5 carbons. Okay, so let's look at this one. 1. And then we have 2, 3, 4, 5 on that one. That could also be a possibility. Here we have multiple carbons. We got 1, 2, 3, 4, 5, 6. Too many, probably not going to work unless somehow one of these gets removed, which doesn't occur. Here we have 1 and then 2 and 3 here from the 2 equivalents. That's not going to work either. So it's between A and B, and let's see if A is correct since that's the shorter route. Right here, this, let me draw this in skeletal. Since it is in condensed form, it's a little bit confusing. Here we have this compound here. which looks like the correct chain. But if we carry that out with benzene, here's what happens. Let's see, 1, 2, 3, 1, 2, 3, 4. We attach this. Here's the ketone that results. And this is a review reaction here. That's Wolff-Kishner's hydrazine reduction of a aryl ketone. Here after that, we are going to get this thing here. This is going to disappear. Organic chemistry magic right there in that case. But that is not what we're trying to make. We're trying to make the alkene right here in this spot. So A is out, B is the answer. Let's see what happens in this. I'm going to trace out B at the bottom here. And I'm going to kind of abbreviate this to speed this up. After step 1, we have bromine added. Bromine goes right there. Step 2, we add in the Mg. Let me just save time and just squiggle a magnesium right in there. Okay, and then after the CO2 gets added in the next 3 and 4 here, we're going to make that into a benzoic acid. That's a really good method of making benzoic acid right there. And that's something that could come up tomorrow. Okay, after step 5 then, we add the thionyl chloride. I'm going to make this benzene now just a pH. This is now an acid chloride. This is beginning to look very similar to what we did before. There's the acid chloride. Ooh, and then we get dibol H in step 6 and 7. Dibol H is another one of those aldehyde making things. So we get aldehyde right there. There's 1 carbon. 7 steps to add that 1 carbon to the ring, and then we're going to add the rest of it right here. The Wittig reagent right here. Let me draw that Wittig in skeletal. Sometimes it helps to draw it in skeletal just to see if it'll work. So here, this skeletal looks like this. And that looks like the correct fishtail that we need to add to make our target molecule. Okay, and that synthesis does work out then. Number 14 here, this one's a little bit easier, and that was a challenge one. With this one, we have a hydrolysis. This may or may not come up tomorrow, not an extremely important one. But here we have a hydrolysis where we're going to break this. We get a ketone on one side, and this is the primary amine. I'll just point to the answer very quickly on that. That's this one here, B, number 14. 15 here is the standard sequence to make the Wittig reagent. So let me sketch that down here in the blank space. Here after step 1, right here we add the Wittig reagent. We're going to replace that chlorine with the phosphonium right here, and then butyl lithium in step 2 will put a double bond in that phosphonium right there, and then once we add benzaldehyde to that right here, benzaldehyde, that's going to connect that to this thing, and there we go. There's the answer. We will get E and Z. Usually the Z, or excuse me, usually the E will be shown. And I'm just going to count to make sure I have the right number of carbons here. Now we have 5 carbons. Here, 1, 2, 3, 4, and then here is the 5th carbon right here. That was one of them. So when you look at your answer choices, one of the tricks is to eliminate carbons. You want to make sure that you have the right number of carbons on that thing.